Okay, 8.4b is about reducing radicals. So the problem 1 says the fourth root of 49. What they're going to want you to do is maybe find a way to reduce this from being a fourth root. Here's all that you would have to do is just say 49, well, that's 7 squared. The fourth root of 7 squared. Now you can take it, you just write it as a fractional exponent. Fourth root means you got a 1 right here, an invisible 1, and your 4 will become your denominator, so you'll write it like this. 7 squared times to the 1/4, or however you should say that. So the 2, of course, is over a 1. So it's 7 squared is like saying 7 to the 2 over 1 to the 1 over 4. You just multiply it out. Watch what we're about to get. We get 7 to the 2 over 4. 2/4. That's something we all know can be reduced to 1/2. Check it out. Now you've got 7 to the 1/2, which you should be very comfortable with by now, just saying, that's just square root of 7. Isn't that a lot simpler than saying the fourth root of 49? So that's all this is about. Okay, let's do number 3. It says the fourth root of 100. Okay, let's just take it out of the radical, 100 to the 1/4. Okay, now let's change our 100 to have a power. 10 to the what makes 100? 10 squared. So 10 to the 2 over 1. I'll just write it. I'm writing it like a fraction, and you can't really see that from there. You write it a little bit bigger. 10 to the 2 over 1 to the 1/4. Okay, so I just wrote it like that so that you can see what I'm doing with my fractions. Maybe later I won't write it as detailed. So 2 times 1 is 2, 1 is 4 is 4. 2/4. Ooh, that will certainly simplify. So 10 to the 1/2, or reduce. Maybe I should have said reduce. 10 to the 1/2. And that's pretty easy. That's just square root of 10. Whoa, that's a lot simpler than saying fourth root of 100. It just isn't as scary. All right, number 5. Let's try number 5. Actually, we did this one at the session. But maybe it will. Maybe you can pause the video and work it by yourself and then check your answer. 5. The sixth root of 625. Wow. All right. Take a deep breath and just right now take it out from under the radical. 625 to the 1/6. Now let's put our 625 in our parentheses. And just think of the 625, make it something to a power. If you're getting comfortable with your 25 powers, your 5 powers, let's think about 5. Let's see, 5 cubed. 5 cubed is 125. The 125 to the something is 165. I think you multiply it by 5 again. Okay. So 5 to the 4th is 5 times 5 times 5 is 125 times another 5. 5 times 5 is 5. 20. 5 times 2 is 10. 11, 12. 6. Okay. 5 to the 4th is 625. All right. So I'm going to write it like this. Instead of 625, I'm going to write 5 to the 4th, which is just 4 over 1. 4 will be multiplied to the numerator. The 1 under the 4 will be multiplied to 6. So your answer is 5 to the 4 over 6. 4/6. That will reduce. I'm going to write that smaller just so that you don't get the feeling it's 5 and 4/6. That'd be a mixed number fraction. We're not doing that. It's 5 to the 4/6. Okay, so reduce to 2/3. 5 to the 2/3. Now, we're not done yet. Put it back under the radical. 2/3 won't reduce anymore, so we know we've done all the reducing we can do. Let's put the 5 back under. 5 to the 2 goes back under. And cubed, the 3, the bottom, goes on the outside. So the cubed root of 5 squared, which is 25. So the cubed root of 25, that is our answer. Okay, let's do number 7. Wow. Okay, that is the 6th root of 25 a to the 4th b squared. Okay, not focused enough. Okay. 6th root, okay. In these problems, we're just reducing. To reduce, we want to get it like a fraction. So just take it out of the radical. That's your first step. Take it out of the radical. 25 a to the 4th b to the b squared to the all to the 1/6. All right. Now we're going to take, let's take our 25 and make it something to a power. So we can take that power and multiply it to the 1/6. 25 is 5 squared. A to the 4th, b squared, all to the 1/6. Now let's let each one get that power multiplied out. 5 squared times 1/6, multiply the 2 to the 1, that's 2 over 6. Okay, that will reduce. 5 to the 2/6. Do the a, let's multiply a to 1/6. A, 4 times 1 is 4. There's an invisible 1 under that. 4, 6. A to the 4/6 and b to the 2/6. All right, those are all going to reduce down. It'll be 5 to the 1/3, a to the 2/3, and b to the 1/3. Look at that. All of their denominators match. So when we put them back under the radical, the denominator becomes the index. So since all of their denominators match, they can all go under that same index. That's cricket. Okay. Oh well. They'll all go under the same index. So 5 to the 1/3 is just 5 to the 1 under here. Thirds right there. A to the 2/3, just a to the 2. B to the 1/3, b is just b. So that is your answer. Looks simpler. That really wasn't that hard. It just looked scary at the beginning. Okay, let's do number 8. The 9th root of 27 times x to the 6 times y cubed. All your next step, we're just trying to reduce, so we want to get it with a fractional exponent. Let's take all of the numbers, write them out, and give them a fractional exponent. The 9th root, well, you write that as 1 over 9. Okay, now we're going to, let's write our 27 so that it has a power. What's 27? It can be 3 cubed. That's the way to write that. All right, so let's write 3 cubed x to the 6th y cubed all to the 1/9. Now it's time to start multiplying out to get your, my mind is blank tonight. Let's just multiply the 3's exponent to this exponent. Well, x's and the y's. Okay, so 3. The 3 times 1 is 3 over 9. 3 to the 3/9. Let's multiply the x. X to the 6/9. Let's multiply the y. Y to the 3/9. Okay. Yes, those will definitely reduce down. Let's do some reducing. 3 can go 3 one time, 9 3 times. So the 3 reduces to 3 to the 1/3. X reduces to x to the 2/3. Y reduces to y to the 1/3. Yes, so now they're all 3 denominators. The denominator is 3. So when we put it back under the radical, perfect. They can all live under a cubed root. 3 to the 1/3, x to the 2/3, thirds y to the 1/3. That's your answer. Woo, tearing some paper there. Okay, let's do number 11. And then we'll probably stop there. 9th root of 125 x to the 6th z cubed. Take them out of the radical. All right, 125 x 6z cubed to the 1/9. It's not very much in focus. There we go. Okay, to the 1/9. All right, make 125 a power. That's 5 cubed. I'm already seeing some powers, some multiples of 3 that are going to reduce down really well. All to the 1/9. All right, now it's time to do some multiplying. 5 cubed times the 1/9 is going to be 5 to the 3/9. x6 to the 1/9 is x to the 6/9. The z will multiply out to be z to the 3/9. Now it's time to reduce. 5 to the 1/3, x to the 2/3, z to the 1/3. They're all thirds. They can all go under a cubed radical. 5 to the 1/3, x to the 2/3, z. 5x squared z, all under a cube root. Nice. All right. And I'm going to do 12. I know we did it yesterday. You can pause the video and see if it just comes back really fast to you. And you might just work this one by yourself. 4th root of 144a squared b 4th c squared. All right, let's give this one a go. Take them out of the radical. 144a squared b to the 4th c squared, all to the 1/4. This is really not as bad as the others. It's pretty easy. All right, 144 is 12 squared. That's pretty good. A squared b 4th c squared, all to the 1/4. Okay, make sure you're seeing this. Okay. All right, multiply out. 12 to the 2/4, a to the 2/4, b to the 4/4. That'll reduce. C to the 2/4. Okay, they're all going to reduce down. 12 to the 1/2, a to the 1/2, b to the 1, c to the 1/2. Okay, they can all live under a square root radical. I'm not going to bother about writing the square on the index because it's a given. If you don't write anything, it's a square root. 12 to the 1, a to the 1, b. Wow. Okay, so b is not b is an actual whole b. It's not to the 1/2. These others are to the 1/2. They have to be under this square root. The c has to be under here, the a, the 12. The b is actually out in front because it's a whole. A b to the 1. There we go. That's number 12. All right, that's all for 8.4b. Good job sticking in there.